Welcome to this explainer. Today, we're going to put on a metaphorical, high-tech, holographic lens to decode the economy. We so often think of the economy as this wild, unpredictable beast. But if you really stripped it down, it operates exactly like a highly sophisticated algorithm. It constantly calculates value, processes constraints, and attempts to optimize outcomes for everyone involved. Over the course of this explainer, we're going to break down the specific core components of that algorithm: consumers, producers, and the efficiency of markets. Okay, let's dive into this.
When you picture a traditional, historical street market, what comes to mind? To the naked eye, it probably just looks like pure chaos, right? Crowds of people moving everywhere, carts stacked full of goods, vendors haggling loudly, buyers browsing. But if we view it through our analytical lens, we don't just see a noisy, busy street. We're actually seeing a massive network operating on an elegant hidden code of supply and demand. Every single transaction happening out there is a discrete data point, and together, they are maximizing total benefits for the participants, all without anyone actively coordinating the whole shebang. To understand exactly how this works, here is our system diagnostics menu for today. 1. Decoding consumer surplus. 2. Analyzing producer surplus. 3. Maximizing market efficiency. 4. The power of the invisible hand. And 5. Efficiency, equality, and market failures.
Section 1. Decoding consumer surplus. Let's start with the very first parameter of our system. We need to reverse engineer the buyer's perspective to figure out exactly how they measure the benefit they get from participating in a market. Now, the bedrock of the buyer's algorithm is their willingness to pay. You can think of this as the absolute maximum input value a user will tolerate before they just walk away from a deal. It's the literal representation of how much they value a good. The metric we use to track their ultimate benefit is called consumer surplus, and it's super simple. It's just the amount a buyer is willing to pay minus the amount they actually end up paying. So if you're willing to pay $50 for something and you snag it for $30, boom, your consumer surplus, your net benefit is $20. Let's process a raw data stream from the source material to see this in action. Imagine a rare Elvis Presley album is up for sale, and we have 3 potential buyers. Taylor is willing to pay over $100. Carrie is willing to pay $80, and Rihanna, she's maxed out at $70. What's really fascinating here is how the final market price totally dictates the benefit. Let's say the market price settles at $70. Taylor gets a massive consumer surplus of $30. Carrie gets a sweet $10 surplus, but Rihanna gets 0 surplus because she paid exactly her absolute maximum. The total consumer surplus for this whole market is simply the sum of those individual benefits. Now, when we scale this up and graph it out for thousands of buyers, all those individual stair steps smooth out into a nice downward-sloping demand curve. The height of that demand curve at any given point represents the value buyers place on the good, their willingness to pay. So, visually speaking, consumer surplus is always the area below the demand curve and above the market price. It's a direct, measurable geometric shape that tells us with precision exactly how much value buyers are extracting from the system. Section 2. Analyzing producer surplus. Let's move to and see how this builds as we flip our interface from the buyer's perspective over to the seller's perspective. Because as we know, a transaction requires 2 willing participants. For sellers, the baseline metric isn't willingness to pay, it's cost. Cost is the value of everything a seller literally has to give up to produce a good. We're talking time, materials, physical effort, the whole 9 yards. The seller's benefit is called producer surplus, and it's calculated as the amount they are paid for a good minus their cost of providing it. Just like buyers are always hunting for the lowest price possible, sellers are chasing the absolute highest price possible compared to their baseline costs. Let's run another data set from the source material, this time looking at house painters. We've got Vincent, whose cost is $900, Claude is at $800, Pablo at $600, and Andy is at $500. If the going market price for painting a house is currently $800, what happens? Well, Vincent definitely won't paint, his cost is way too high. Claude exactly breaks even, but Pablo, he gets a producer surplus of $200. And Andy, who is the most cost-effective painter of the bunch, gets a producer surplus of $300. The total producer surplus at that $800 price point is a solid $500. When we put these 2 concepts side by side, the pure genius of the market algorithm becomes incredibly clear. In a voluntary market transaction, both sides win. It's not a zero-sum game. Buyers get something they value more than the cash they parted with, which creates consumer surplus. Sellers receive more money than it costs them to provide the good, creating producer surplus. The system inherently generates value out of thin air, simply by matching the right people together. Section 3. Maximizing market efficiency. Now that we've mapped out both the buyer and seller parameters, we can combine these data sets into the master equation for the entire market system. This brings us to total surplus, which is simply the sum of consumer and producer surplus. Because the amount paid by buyers is exactly equal to the amount received by sellers, those two variables actually cancel each other out in the math. What we're left with is this. Total surplus equals the value to buyers minus the cost to sellers. This single, elegant formula represents society's total economic well-being. Think of it as the overall size of the economic pie. And our primary goal as a society is usually to make that pie as absolutely massive as possible. When a market successfully makes that pie as large as it can possibly be, we call it efficiency. If an allocation is not efficient, it essentially means potential gains are just being left on the table. For instance, it's a huge glitch in the system if a high-cost producer like Vincent is outpainting a house instead of a low-cost producer like Andy. Moving that job over to Andy lowers the total cost and instantly increases total surplus. True efficiency ensures that goods are produced by the sellers with the absolute lowest costs and consumed by the buyers who value them the most. Section 4. Power of the Invisible Hand. So who is actually calculating all this? Who ensures that the right buyers meet the right sellers to achieve this perfect efficiency, especially without any kind of central control panel? As the legendary economist Adam Smith pointed out, an invisible hand guides the marketplace. There isn't a single consumer or producer out there actively trying to maximize total social welfare. They are literally all just looking out for their own self-interest. But the market price itself acts as a massive signaling mechanism. This legacy code organically pushes buyers and sellers toward a natural equilibrium where supply perfectly meets demand. And right at that specific equilibrium point, the total surplus of the entire market is naturally maximized. So the crucial point is that a benevolent social planner looking to maximize the economic well-being of society doesn't actually need to intervene in a perfectly functioning market. The outcome is already fully optimized. This insight is the very foundation of laissez-faire economics, which is a French expression that essentially means leave it be or let people do as they will. The algorithm is entirely self-optimizing. If you just leave the market alone, it will automatically find the most efficient allocation of resources all on its own.
Section 5. Efficiency, Equality, and Failures.
But like any highly complex system, the market algorithm isn't perfectly flawless. We have to look at the glitches in the matrix. What happens when the system parameters conflict, or when the code just breaks down entirely? First up, there's an inherent trade-off between efficiency and equality. Efficiency is all about maximizing the total size of the economic pie. Equality, on the other hand, is about making sure everyone gets a uniform, fair slice. Market algorithms reward people based on their ability to produce things that other people want, which means, for example, a star basketball player is naturally going to earn a lot more than a world-class chess champion. To try and increase equality, governments might step in with taxes or welfare systems. But redistributing income can unintentionally reduce the core reward for hard work, which might cause people to produce less overall. So often, when a government tries to cut the pie into more equal slices, the overall pie itself actually shrinks. Beyond that tricky trade-off with equality, sometimes the algorithm just straight up fails to maximize the pie at all. We call this a market failure. The invisible hand is undeniably powerful, but it's not omnipotent. When an unregulated market fails to allocate resources efficiently, leaving total surplus unmaximized, the system is going to require a manual patch or some form of outside intervention. The source material flags a few specific system errors we need to watch out for. One is market power, like a monopoly, where a single dominant actor can manipulate prices, completely breaking the competitive equilibrium. Another major error comes from externalities, and this brilliantly illustrates a flaw in the basic algorithm. If a paper plant creates toxic dioxin pollution, it negatively impacts innocent bystanders who aren't even participating in the paper market. The buyers and sellers are completely ignoring the true cost of their actions to society. Because the unregulated market turns a blind eye to this external damage, it produces way too much paper and way too much pollution, which requires a government policy patch to correct the error. Which brings us to our final thought for today. The market is an undeniably incredible, highly efficient algorithm for generating wealth and maximizing total surplus. But as we've just seen, efficiency doesn't guarantee equality, and externalities can bypass the system's internal logic completely. So, if a perfectly efficient market algorithm maximizes the overall size of the pie, but still leaves some people without basic, fundamental needs like food or healthcare, is it truly the ultimate system? Or is it just one piece of a much larger, more complex societal puzzle? Thank you so much for joining this explainer. I really hope it provided a powerful new lens for viewing the economy, and I highly encourage you to keep pondering the limits and the incredible applications of these fascinating economic models.